Hey everyone, hope you're doing well. This is going to be a video on solving 2x2 systems by using substitution, okay? So we went over graphing yesterday, but you don't always have graphs, and graphs always aren't the most applicable method, but substitution is algebraically, and you can always do it as long as you got a piece of paper. So this first question, right, solve the following equation, all right? You guys can do that as a warm-up, okay? I'm going to start right here, okay? Because this is really what starts tying into the substitution. So it says, if x equals 3 and y equals x plus 2, how can we solve for y? Well, you can probably guess by the name, and I'm sure most of you can figure out that if you know x is 3, then what you want to do is substitute that in for x, right? Because you know that y is x plus 2, so we know that y would be 3 plus 2, which is 5, okay? And that's a really, really easy and basic method, but that's showing you, what you're doing with substitution, right? And so we can look at, a slightly harder one, but one that's going to shed more light on what we're going to be doing. What if x is, y plus 3 and y plus x equals 9, right? So we can still do this substitution here. And the thing is that just an equation like this, you can't solve that because you have two variables in an equation. Your goal is always to get it down to one variable in an equation, right? So we're going to substitute y plus 3 in for x. And in doing so, we are eliminating the x from the equation and putting in two y's. Now we can combine like terms, right? Now we can solve and actually get y, right? Y is 3. And so this is a method that, we're going to be practicing today. And in order to do the method, you have to get a letter by itself, right? We call that isolating a variable. So you got to get at least one letter by itself, and then whatever it's equal to, you can substitute that in for the second equation. That's why you kind of need two equations in order to do this. All right, so here's your steps right here. You can read through this. I'm just going to talk through them and show you. All right. So we have two equations here. All right. First, you want to, ask yourself, do I have a variable by itself? All right. The answer is yes, we do. So we're going to take this right here and we're going to substitute it in for x. Now, the equations can get, as complicated as we want them to get. But the key is that you write your equation down exactly as it is. You put parentheses where your x was. And then inside the parentheses, you put whatever you're replacing the x with, right? So we're substituting in negative 3y plus 4 in for x. So we have everything else the same, right? And now we've got, a semi-complicated problem to solve. And so that involves solving for y, that involves usually having parentheses, usually having to distribute. Negative 2 times negative 3, that's plus 6. Negative 2 times 4, that's minus 8. This makes 8y, and once you get down to here, we've solved these equations so much. Negative 24 plus 8, that's negative 16. Divide by 8y equals negative 2. So there's one solution, okay? Once you have got your first solution, this is where step 4 comes into play. You have to substitute your answer from step 3 back into one of your original equations. Now, I would always recommend substituting it back into the equation where you had the other variable by itself because it's already solved for and you don't actually have to solve again. So we know x equals negative 3 times y, but now we know y is negative 2, so we put that in, plus 4. And so negative 3 times negative 2, that's 6, plus 4, so x equals 10, all right? And so those are our two solutions. Now, if you remember from graphing, we're actually finding intersection points by doing this between the two lines. So you want to write your answer as a point. So our answer is 10 comma negative 2. All right, and that's how your solution should look. So like on a test, I want to be looking for that point. All right, I don't want to have to dig through your work to find x and y. So that's how you do one of these problems. Now we're going to move and we're going to do 2 more on the back. Sometimes you don't always have a letter by itself, right? We have no letters by itself here, or should I say no letters already isolated on one side of the equation. However, once you realize, okay, we need to isolate a variable, you need to look for what's going to be the easiest variable to isolate, right? Not that one, not that one, not that one, right? They all have letters in front. This y has no coefficient, right? It has a coefficient of 1. So this one's going to be the easiest one to get by itself. All we have to do is move that 7x over to the other side. Okay, and so we've got that done. All right, now y is by itself. Now we're going to substitute this in for y in our other equation, right? It's always got to be back into the other equation. So we're going to plug it in right there. And so now we've got 6x. Remember, write it exactly as it is, but just replace the y with a parentheses. In the parentheses, we've got negative 7x plus 22, and that equals negative 28. So now we have to solve this. So again, remember, most of the time you're going to have that parentheses, so you're going to need to distribute. So we've got negative 5 times negative 7. That's 35, so it'll be 35x. Negative 5 times 22, I think that's 110, but you can use your calculator. Combine like terms, 6x plus 35x, that's 41x. Add 110 on both sides. So we got 41x, 90 minus 8, 82. Yeah, so this is going to be divided by 41. This is going to be x equals 2 here. So there's our first one. Now, remember, I said you can choose where to plug this back in wherever you want. You could plug it in here, you could plug it in here, but I always say the easiest spot is to plug it in here, right? So you can plug it back into the equation that you made, right? And so by doing that, we've got y equals negative 7 times 2 plus 22. And, you can kind of just do your order of operations. You don't have to worry about solving again. So we got negative 14 plus 22, which is 8. All right. So y equals 8. And so our solution, remember we want to write our solution as a point, is going to be 2 comma 8. All right. So that's just one example of how this could look. Looking at a different example, all right, we want to, get a variable by itself, all right? Do I want to get this or this by itself? Probably not, because then I'm going to have to divide 13 by a number, and 13's prime, so we don't want to divide 13 by anything. However, here we got 2 easy numbers, 6 and 18. Those are both even, so we can easily get this get this x by itself by dividing by 2. And so that gives us x equals 3y plus 9. Now we've got an x by itself, so now we're going to plug that in for the x in our other equation. So that gives us 3 parentheses 3y plus 9 minus 2y equals 13. And again, look, the equation we're solving here is really similar every time. Distribute 9y plus 27. Combine like terms, 9y minus 2y, that's 7y. Subtract over the 27. And then divide by 7. We get y equals negative 2. All right. So now we've got our first variable. Now we need to take that -2 and we need to plug it back into our other equation. We've already got x by itself in this equation, so there's no need to give ourselves extra work by going up to one of the original equations. We're just going to plug in -2 right there for y. 3 times -2, that's -6 plus 9, that's 3. So x equals 3 and y equals -2. So 3, -2, and that's our answer. So hopefully this is familiar to you. You definitely have done this before. If you didn't remember, hopefully this helps. All right, you've got not a lot, just like I think 1 page of practice, all right, that I want you to do. So work on that, check your answers with the key. If you have any questions, let me know, and have a great day.